A custom preloader is the easiest way to do it, but then we also created a Loom application, which is just a Spark application that gives us some lower level hooks into the actual startup of the application.
James, I had a question there. It's my favorite question to ask you, you know. You said that you can intercept RSLs, but are RSLs signed by Adobe so that they can't be changed?
We'll talk more about RSLs in a little bit, but essentially, when RSLs, Flex Framework or RSLs, any RSL is loaded, by the time they're loaded in just the same way that any other SWF file is loaded. So that means that we can intercept the load and modify the bytes and then give them to Flash Player. It's perfectly legit. The real reason why the RSLs are signed is to get them into the Flash Player cache. The signatures are not used for actual validation by Flash Player for actually running the contents of the SWF file. They're only used for storing in the cache. So we intercept the SWF loading, and then we have this concept of a patcher. And patchers in Mixing Loom really just modify the SWF file, modify the loaded bytes on frame 2. So patchers can be synchronous or asynchronous. You can have multiple patchers, so you can combine as many patchers as you want. You can change patchers, so let's say you want to have one patcher that's doing some modifications, another patcher that's doing additional modifications. You can do that.
One patcher that modifies the output of another patcher?
Absolutely, yeah. And then they can do anything they want. As we've said, patchers can do anything they want to the byte.
Anything that you could have originally written in ActionScript, and some things you can't, as a matter of fact.
Exactly. Yeah. Because you are working at the bytecode level, you can do anything. And there are things that ActionScript allows you to do through the constructs of Flex and how it generates bytecode, but then there's even lower level things that you can do that aren't exposed through Flex when you just get down to raw bytecode.
Good example. Everybody heard of Alchemy? Okay. Alchemy actually created a number of these operation codes, these ABC codes, which the Flex compiler doesn't use. So it actually turns out the Flash Player is capable of doing a number of things much, much faster than how the Flex compiler writes the code. So you can, through these types of things, actually go through and say, well, that's very interesting, Flex compiler, that you chose to do it that way, but I'd like to make my SWF run 30% faster, and actually go through and change out bytes to make things run much, much faster at runtime using this concept. We didn't finish this one, but one of the prototype ones we had was by installing Mixing Loom on your SWF just got 30% faster. These are the types of things you can very easily do.
So you may be familiar with Joa in Germany, his Apparat project. He uses post-processing on a SWF file to speed up an application by doing some bytecode modifications, enhancements. He'll take loops and unroll them. He'll take operations that can be condensed and make those condense those operations. So instead of doing that post-compile, we could, in Mixing Loom, do that actually at runtime. So you may pay a little bit of a performance hit up front loading the application, but then once the application is loading, it would continue to run faster than it would otherwise.
Okay. So the basic approach for using it is that there's a custom preloader, which either implements an interface or extends ours. And that custom preloader, when things arrive, calls patchers. So what we do is we register these patchers with our custom preloader, and then these patchers are called and said, okay, here's the bytes to the SWF file, do whatever you'd like to them. We don't care. We don't want to know. Do whatever you'd like. When you're done, tell us, and then we'll call the next patcher. And when all of the patchers are done doing whatever they want to, then we give those bytes to the Flash Player and we move on. But every patcher has the capability of changing it in any way they would like to. Fair enough?
Yeah. Okay. So to create a patcher, this is just an example of a sample patcher. And so what you do is you extend the abstract patcher, and then you have this method apply that you override, and you get a couple things in there. There's an invocation type. So you may need to know what am I being invoked on, because Mixing Loom will give you different kind of points in time which you can invoke, whether it's a module, whether it's an RSL, whether it's frame 2.
Right. So example, I'm getting, this is the byte that you're getting right now, because you'll be called a couple times. The bytes you're loading right now are frame 2 coming in. The bytes that you're getting now are a runtime shared library that someone specified being loaded. The bytes you're getting now is the application went to go load a module, because maybe I want to modify things in the application, but maybe when a module loads, I have to do a little work as well. So you get called with these invocation types at different times for different types of invocations, so you can decide what to do.
Yeah. And then the other thing you get is the Swift context. That's a mixing loom object, and that's what actually holds the information about the Swift file that you're being given. So you can take Swift context.swift tags. Swift tags are, we didn't describe Swift tags, but essentially a tag in a Swift file is so you've got Swift, you've got the frames, and then within an ABC frame, or within a frame, you have different types. So they're called tags in Swift. So there's a do ABC tag, which will be a block of ActionScript bytecode. And what's interesting is that the debug and release versions, when you do a debug build or do a release build of a Swift file, they actually use those do ABCs differently. And I don't know if we want to go into the details of why, but essentially there's some Swift optimization for file size that they can do in the release mode where they stuff everything into one do ABC, but in debug mode, every class is actually in its own do ABC tag. So that's just something you have to be aware of. When you go through the Swift tags, you have to get some information about the Swift tags. What are the classes that I'm operating on, and other meta information about it. So all that's in the Swift tags property on that Swift context. We're using underneath the covers AS3 Commons bytecode to actually give you that metadata, that information about what's actually inside of the Swift tags. So once you're done doing any modifications that you want to that Swift context, you just call the invoke callback method on the abstract patcher, and then that lets the patch manager in Mixing Loom know that you're done, and so then it will continue on to the next patcher if there is.
Right. And the reason this is important is that this example might be synchronous. For instance, maybe all I need to do here, very simply, is I need to just change a couple of bytes. But maybe I need to go load an XML file, which is going to give me information about what I'm going to change, and that would be asynchronous. So this patcher concept allows us to have this callback so that we need to do something asynchronous. We can go off and take as much time as we need, and when we're all done, we tell it we're done.
Okay. So you do need to create your own preloader, but it's very simple. You just extend the abstract preloader, and then you call the setup patchers method or override it, and then you register any patchers that you want to run here inside of your preloader. So one important thing to point out is that everything that we do in these patchers actually ends up going on frame 1. So we have to, anytime you put something, link against it into a preloader, like if you ever put like a button, a flex button into a preloader, that will make your whole application move from frame 2 to frame 1 because everything in the preloader needs to be on frame 1 so that you can actually display whatever it is you're trying to do on inside the preloader.
Well, maybe let's hold on to that for a second. Is that inside of these individual frames, each frame needs to be let's call it self-sufficient or self-reconciled, right? Meaning that when we load frame 1, the reason it works with the Flex application is all the things in frame 1 don't have dependencies on everything that's coming later. They can only have dependencies on things that have already been loaded. So if we were to put, for instance, a Flex button in the preloader, that would mean that, well, button extends from button base, which comes from a UI component, which comes from a Flex sprite, which means every one of those things needs to move into frame 1 to make that work. And of course, UI component has a reference to a style manager, which has a reference to some other single pin. So what happens is Flex, the compiler, figures this out, and it moves more and more of these things here. It's very possible to suddenly have an application that's supposed to be a very small frame 1, followed by a very big frame 2, and without much care, it's easy to make a very big frame 1, followed by a tiny little frame 2. We don't want that. So things in here need to be very low level, because everything that you reference in here will get moved.
Exactly. And the Flex compiler deals with that for you. Whenever you use a preloader, the Flex compiler knows anything that is a dependency of what you're using in your preloader must go on frame 1. So it figures that out for you. So then, finally, to use that preloader, just the standard set the preloader in your application. All right. So So let's take a look at a real-world example of this. We've got a sample in Mixing Loom called the sample XML patcher. And what it does is it reads an XML file that references Mike's example of doing something asynchronous. And
I was kind of referencing your example.
Oh, that's right. Modify the classes on frame 2. So this one in particular will, based on some information that was in that XML file, do some modifications of the actual content on frame 2, the Swift content, and then what we already pointed out. So let's take a look at this one actually running here. So this is the main application. So you'll see it's a pretty standard application here. I've got my preloader registered, which I'll show you in a second. But then we've got this button down here. And the button, all that it's going to do is create a new instance of this foo object and then call the getBar method on foo. That's it. That's all when we click the button.
What does getBar do?
So let's take a look at getBar. All that getBar does is return bar. Okay? So let's first just run this so you can see what happens here.
Is the preloader right now, James?
What?
You have preloader still, right?
Yep. Yeah, you can. So this is that application. Remember, button, all it does is return a string when I click it, right? So let's click it. Oh, and for some reason, somehow, we're actually changing the background color of this application. Wait, how did that happen? So let's go take a look at how that happens. So first, our preloader. Let's go check out the preloader here. So in the preloader, like you saw on the slide, we're registering a patcher, and the patcher that we're registering is the sample XML patcher, and we're passing a parameter to it. In this case, interceptors.xml. So, there. Let's go check out first that XML file, which is
It's in the app.
there. So this is just a construct that we came up with for the sample. This is just going to describe what classes to patch and then what to call when we patch those. So this is a kind of standard AOP concept where we're going to say, all right, here's an aspect that we want to apply. So this in this case, it's just this foo interceptor. And then we have to specify what we want to apply it on. So I'm saying in the Swift tag for blah/foo, so this is saying when you encounter a Swift tag with this particular name, take all the classes and all the methods within that Swift tag, and essentially whenever a method is invoked, then call this foo intercept all method. Okay, so that's just the XML description that we're loading.
So in other words, shim, before every one of those methods is called, call us first, and then call that method. Basically, we intercept all calls to that method, do something else, and then still call the original method. But we have an opportunity to do more.
Yeah. So this is the actual patcher that's actually doing the work. So if we look through here, what we'll see is that we've got the constructor, we're saving the URL, and then if we're doing the frame 2 invocation, what we're going to do is save off the Swift context. That's not the best way to do that, but just a demo. And then we're going to use a URL loader. So we're not using like HTTP service because that would move HTTP service and all of its dependencies to frame 1. So we have to be, make sure we're not causing that sort of thing to happen. So we're using URL loader, and we're loading that XML file. And then once we finish loading that XML file, we do some work. So we're going to first parse the XML into an XML object, and then we're going to go through and actually do some modifications. So this is where we actually start doing the modifications. We're going through the Swift tags. We're making sure that these are the Swift tags that the interceptor.xml file said to mess with. And now we actually start using like the ABC deserializer from ASR Commons bytecode and actually messing with the actual.
Can we look at that interceptor class real quick?
Which one?
The actual interceptor class that we're calling.
Oh, yeah, sorry.
Maybe do a little bit.
Yeah, that's a good point. Feature. Where? Foo interceptor. Okay. So this is what we're actually adding to all of the methods in that foo Swift tag. So flex globals, top level application, set style background color to a random color. So that's why the background color was changing when we clicked that button. because we'd actually added a call to this method onto that get bar method on foo.
So we could have done the same thing by changing the code in get bar, right? We could have gone in and we could have changed it to call this method. But then we have to maintain it, and we have, if we want to change it again, or if we want to, for instance, have it work different in testing than in production, we have to have multiple versions of the application compiled. Here, to make something work differently later, or make it work differently in testing versus production, we change an XML file, and it is able to apply one or the other. So it really is the same as having called that method yourself. Just so happens that we're weaving that call, we're bringing that call into what we want at runtime.
So